Good afternoon. Now we will discuss about a few more chemical properties of carboxylic acids itself. And previously I was given this coal-based electrolysis. Excuse me. What is this? Coal-based electrolysis. What I was given here, suppose CH3, COO, Na. When react, it means water we will take, and on electrolysis, on what sir? Electrolysis, you will get CH3 single bond CH3 plus CO2 plus NaOH plus H2. Who are the anode products? CH3 means this ethane as well as CO2 are anode products. Excuse me. These two are anode products, and this NaOH and H2 are cathode products actually. Okay, so anode products and cathode products. So what I said in previous, do you remember? This methyl group is there. This methyl group means this alkyl group. Forget about this group I said. This alkyl group has how many carbons? One carbon, methyl. So double we have to take. So why I given again? So to understand its mechanism. Okay, sir. So let's see what happens first. CH3, COO, Na. So actually 2 moles they won't give, but just for understanding we have to take 2 moles because 2 moles will react in this. So this is on electrolysis. On electrolysis, what happens? This CH3COOH will ionize. That means CH3COO minus plus Na plus 2 moles. CH3COO minus plus Na plus. Now towards anode, who will go at anode? What reaction happens? Let's see. Anode means what? Positive electrode. Towards anode, which ions will go, sir? Negative ions will go, because anode is what? Positive. Anode is positive. Towards positive, negative ion will go. Who is a negative ion? CH3COO minus is the negative ion. So that will undergo oxidation. CH3COO minus, it turns to CH3 COO dot. So 2 moles if you take it. So CH3COO dot plus 2 electrons. Because what happens at anode? At anode, oxidation takes place. What is oxidation here? CH3COO minus. Okay, minus means 2 electrons here. So 1 electron remains and 1 electron will go. So from 2 moles of electrons will remove, and 2 moles of this free radical will form. Okay, sorry. Look at this. At anode, what happens? I said oxidation. So anode is positive. So towards positive electrode, this negative ions will go. This is actually anion part. This anion part move towards anode, and actually 1 minus means 2 electrons, as I said in previous. So 2 moles of negative charge means 2 electrons lost. So you are having CH3COO dot and 2 electrons. Oxidation takes place. Correct, sir, everyone? So 1 mole of negative charge, 1 dot and 1 electron lost. So 2 moles of negative charge, 2 dots and 2 electrons lost. So this reaction happens at anode. So next what happens? This CH3, C double bond O dot actually. Okay, 2 moles I am taking. So next here homolytic cleavage takes place. Homolytic cleavage. Okay, so homolytic cleavage of which bond takes place? The CC bond will homolytically break. So how this homolytically break like this? Half arrows we have to represent for homolytic cleavage. Then what happens? So CH3 dot, that means what you have here? 2 moles of CH3 dot, 2 moles of CH3 dot, and this C double bond O and double bond O. So C double bond O and C dot O dot. So double bond. Understood, sir, clearly? So what happens now? Very clear. So 2 moles of CO2 you have. So now this CH3 dot and one more 2 moles of CH3 dots. So both will combine now. So that means what you have? CH3 single bond CH3. So what I said in coal-based electrolysis understood now? So here CH3 COONA turns to ethane and CO2 NaOH plus H2. So these two are forming at where I said? At anode I said, and these two forming at cathode I said. Correct, sir? And one more important thing is here, what is the alkyl group? For that, double the number of carbons you will have in alkane. So this is very important. So this is methyl, so 2 carbons. Understood, sir? If you taken even benzoate you taken, this is actually anode product and you have tried cathode product also, right? So this is reactions happens at actually anode. So reactions happens at cathode, let's see now. Okay, so at cathode what happens? Cathode means negative actually, negative electrode. So at cathode positive ions will go. That means Na plus ions will move towards cathode actually. Who will move towards cathode? This Na plus ions will move towards cathode. But you remember or not, I don't know, but SRP values I was given in electrochemistry. SRP values, standard reduction potentials. In electrochemical series I was given, electrochemistry chapter, please revise. Na plus ions SRP value and water SRP value you compare. Water SRP value is more. So water will undergo reduction instead of Na plus. What I am saying, understanding? SRP of Na plus is less than SRP of water actually. So here water also there, no? So actually what we think at cathode, what happens? Cathode reduction takes place. What takes place? Reduction takes place. So what kind of reduction takes place we think? Generally Na plus ions will take electron. So 2 moles of Na plus is there. So 2 electron and converted to 2 Na we think. But this is absolutely wrong. This one is wrong. So this won't happen. So why? What is the reason? Na plus ions reduction potential is less. Reduction potential is more than undergo reduction. SRP value is less than undergo oxidation. So whose SRP is more? Water SRP is more. So who will undergo reduction? Therefore water will undergo reduction. What I said, understanding? So here you have to know this SRP value is more than undergo reduction. Very important. Got it? So now who will undergo reduction? Therefore water will take electrons and take converted to OH minus plus H2. Understood? So water undergone reduction here. This is very important. So now what happens? Now these Na plus ions which move towards cathode, they will combine with OH minus ion and form sodium hydroxide. Many times we discussed this, even in electrochemistry, electrolysis process we discussed. So at cathode these two are products, and at anode these two are the products. At cathode NaOH and H2. See, at cathode who is the product? NaOH is the product and H2 is the product. So this is about electrolysis, coal-based electrolysis. Please note it down. Okay. So coal-based electrolysis mechanism we observed. Understood, sir? So even in coal-based electrolysis, even aromatic compounds, suppose sodium salt of benzoic acid, suppose this we take COONA and plus H2O, and on electrolysis what happened? Same 2 moles we have to take. Cold base means 2 moles. And this given, electrolysis given. Very simple. Forget about this part. Now this benzene ring, we have double in product. Here methyl ring, we double in product or not? Methyl, methyl. Understood? Now benzene ring, we have to consider double like this. C6H5 and C6H5. So benzene ring means C6H6, no sir, C6H5, why you are saying? So instead of one hydrogen, we have this group. So instead of hydrogens, these two benzene rings was attached, combined. So this is called actually biphenyl. What is this? Biphenyl. Understood sir, everyone? So this is very important, and this is called cold base electrolysis. And one more thing, C6H5, suppose COONA given, and the given sodium sodium hydroxide and calcium oxide. What is the mixture we called? NaOH plus CaO is called, I said no, soda lime given. See the difference? Same reactant, sodium benzoate. What is this? Sodium benzoate. So sodium benzoate on electrolysis, biphenyls. Sodium benzoate with soda lime, do you know what is the product? This COONA and NaO will go. So C6H5 and H. That means you are having C6H6. What is this? C6H6. Benzene is the product, and along with that you have Na2CO3 is the byproduct. What is the byproduct here? Sodium carbonate is the byproduct. Very important. And main difference between electrolysis and with soda lime. Same reactor. Carboxylic acids only. We are in that topic only. Okay. So very important. Please note it down this also, everyone. Now cold base electrolysis for alkenes. Cold base electrolysis for alkenes and alkynes we will see. So for alkanes we discussed. Now cold base electrolysis for alkenes preparation. For this alkenes and alkynes, we have to take salts of carboxylic salts. Okay, which carboxylic acids we have to take? Do you know? Dicarboxylic acids. Okay, so here if you take this CH2 and COONA and CH2 COONA, this is on electrolysis. Okay sir, on what? On electrolysis. What happens? Very simple. Remove this and put double bond here. Got it what I am saying? So remove this COO and this COO completely and put double bond here. That's the product. So dicarboxylic acid salts will be taken here. Sodium salt of, you know this, CH2COONA, CH2COOH and CH2COOH. Do you remember? That is what we call succinic acid. Okay, so that we called as sodium succinate. Why I am giving names? They will ask like that. Sodium succinate on electrolysis, the product is. First of all, you must know what is succinic acid. Succinic acid means you know COOH. So CH2COOH and CH2COOH. So instead of H, you have sodium. So sodium succinate on electrolysis, you are having what I said. Just forget about this COONA and COONA. Remove the COONA, remove the COONA, put the new bond between these two carbons. That means what's the product here? CH2 double bond and CH2 along with that carbon dioxide 2 moles and NaOH and plus H2 2 moles. So these two are forming at anode and these two are forming at cathode. Same story, no doubt. So cathode reactions same. Anode reaction only we have. Anode also similar to previous. So in mechanism at anode what happens? Let's see. First it will split what? CH2 COO minus and CH2 COO minus, and Na plus will separate. dissociation takes place on electrolysis. So oxidation takes place at anode. At anode what takes place? Oxidation. So what happens now? CH2 COO dot and CH2 COO dot. From 1 minus charge, 1 electron. That means 2 electrons removed. From here 1 electron, from here 1 electron. 2 electrons removed, remaining 2 electrons. So remaining what you have here? CH2 COO dot and CH2 COO dot. CH2 COO dot, I will write for our convenience C double bond O dot, and here also C double bond O dot. What happens, sir? Next, it is the second step. What happens next? So very simple, homolytic cleavage of this bond and homolytic cleavage of this bond. Half arrow homolytic cleavage means CH2 dot and CH2 dot plus CO2, C double bond O, C double bond O, C double bond O, double bond O, C double bond O, double bond O, 2 moles. Okay, so you have CH2 dot and CH2 dot. So further you can write it as CH2 double bond CH2 you have. Got it, sir, everyone? CH2 double bond CH2. What happened here? This removed, this removed. So between these two, one more bond, pi bond plus bond. If you want alkyne, what you have to take? Fumarate you have to take. This is succinate. When you taken, you got alkene. If you taken fumarate like that, means double bond. Do you remember C double bond C, COOH and COOH, fumaric acid and malic acid, cis trans I was given. Those if you consider, then you will get alkyne. Okay, what you will get? Alkyne. But suppose I will give you this example: CH3 and CH COO Na and CH2 COO Na. This with water on electrolysis, what is the product? Understanding? So here same story. This will remove and this will remove and double bond you will have here. So on electrolysis you have product CH3 and CH double bond CH2. So 2 moles of CO2 and 2 moles of NaOH plus H2. Same story. So what happens between these two carbons? You have a double bond. That's it. Okay, sir. So if you consider, so please note it down, sir, everyone. This is CH2. Got it, sir, everyone? So this is very, very important. Please write down. And if you consider triple bond, what, sir? Sorry, if you want alkyne, so you have to consider double bond here. So for alkynes preparation, okay. So you have this CH and CH. What is this? Sodium fumarate. What is this? Sodium fumarate on electrolysis. Same story. COONA remove and put triple bond here. That's it. That means what you have? Alkyne at anode. Okay. We discussed about Huns-Dicker reaction. Do you remember? Huns-Dicker's reaction. What is Huns-Dicker reaction? Do you remember? RCO, silver salt of carboxylic acids, on treating with chlorine or bromine, alkyl halides. If you taken I2 and heating, then what you have? Ester. Forgot? So just I will remind you. See this? CH3COO, CH3COOH, when react with sodium hydroxide, what happens? So CH3COONA you are having. This CH3COONA, when react with silver nitrate, AgNO3, then you will get CH3COOH, okay, plus NaNO3. Forget about it. So this is silver salt of carboxylic acid, silver acetate. This silver acetate CH3COOH, when react with Mr. chlorine on heating or you can use CH3COOH and bromine. What happens? Very simple. You are having this CH3Cl here CH3Br here. This CO2 and AgCl. CO2 plus AgBr. Correct, sir? This happens here. But if you take iodine, this CH3, COOH plus I2 on heating, then what happens? Ester formation. Please remember, very important, we discussed in alkyl halides preparation. If you take an I2, then the product is CH3, COO, CH3 plus AgI. Okay, plus CO. 2 marks. Understood, sir? So this is about Hansa-Becker reaction. So maximum of the reactions we discussed, and even with Grignard reagent, suppose RC double bond OCl with RMGCl, RMGBr like that. So this is R minus, this come out here, Cl will go. Like that we discussed or not? Those all reactions over already. So what you have here, RC double bond O R plus MgCl2. This you have. So very important, please note it down. And freshly tomorrow we will discuss, we will start amides